On this computer. All right, so why do winners always win?
Because losers always lose.
Beats me. Yes, I know those are very, very corny.
Oh.
Okay, so we're gonna do 14.4. So we're gonna be talking about surface area. So this is kind of going back to what we were talking about in chapter 11. We were talking about polyhedrons and stuff. So we're going to be talking about decomposing 3D shapes again, and we'll talk about finding surface areas and volumes of these prisms, justify relationships among the formulas for the different polygons, and use area formulas to solve problems. So representations, connections, geometry, measurement. These are primarily taught with 6th and 7th grade, and obviously 8th grade and so on. Because you won't be doing very elaborate formulas with surface areas, but you might do volumes, which are kind of easy to calculate. Because these are very multi-step kind of problems. So let's look at this box. So consider this cereal box.
Are you guys able to hear me still?
Yeah, we hear you. Do you not hear me?
I hear you,
Okay.
but Austin can't
Okay,
hear
well,
you.
I can't hear anyone
Oh
at
no.
all for some reason.
We can hear you, Austin.
Oh, there's lots of chat. Sorry, my chat box got hidden. Oh, okay.
Let's see if it works.
Yeah.
We're experiencing some technical difficulties.
Are we good, Austin?
Austin.
Austin?
Austin.
He wasn't the only.
He logged off, I think, for a second.
Oh,
Well,
yeah,
I tried
that-
logging off and logging on. And I still hear no one.
Can you hear me?
Gonna assume no.
No, I don't see anything that I could. As like I can mute him, but I don't know what happened there. So
Speaking, can you hear me?
yes.
Okay. Yes, my headset is plugged in. Everything's on.
I was gonna
I
say.
don't understand.
Me and Sophie are just asking the most basic questions.
Is the audio actually being sent? Because I had that problem before. because I had that problem last time I was using my headphones, and then I switched to regular computer audio, and then when I put my headphones back in, it didn't work. So
I just unplugged them.
Can you hear?
And I'm still not hearing anything.
okay, that's a bummer. Thanks, Sophie.
You're welcome.
And I think there's a way to do closed captioning. Let's see if that works. Assign someone to type. Oh yeah, you have to assign somebody to type. So I don't want to do that. Okay.
Can you hear now? I heard you talking. That's the only reason why.
Oh, that's me. But yeah. Well, Austin, just yell at us if we need you to if we need to retype something here for you. Okay? Oh, he didn't hear me.
I can hear now.
Oh, you're there.
Oh!
Okay, yay. All right. We got it all figured out. Okay, and how many of us are here? We're missing somebody. Who are we missing?
Is
Brittany. Brittany's here.
Is Amelia here?
Amelia. That's who we're missing, right?
Yeah.
Anybody?
Hi, Emily.
Anybody heard from Amelia?
I can text her and see what's
Okay.
up.
All right. So let's.
She was here yesterday. If you didn't see that she logged on, like after you said she wasn't here.
Oh no.
So if you marked your absent, she was here yesterday.
See, what is my Zoom thing is flashing at me again? Hold on. Oh, I don't know what that's
I
doing.
just happened to see her log in after we all started.
Oh. Okay.
No, she'll talk. She'll say something.
Yeah.
Mhm.
All right. Okay, so let's get started on this because I would like to get through some of this material as much as possible. So, all right, so we're talking about surface area. So we're looking at this cardboard box, right? And so if we cut it apart, we have this top, this bottom, and the two sides, and then the front and the back, right?
I agree.
So to find the surface area of a right prism, like this cereal box, we'd find the sum of the areas of the rectangles that make up the lateral faces and the areas that make up the top and bottom. So the lateral is the sum of the areas of the lateral faces. So if we're looking at the lateral faces, those would be what are not the faces that are the base. So if this was a base, which is the top, and that's the bottom, these would be the laterals. Lateral, not latera. And then the surface area would be the total of the areas of the lateral faces and the bases. So if we wanted to find the lateral area, if we found the area of each of these lateral pieces, could we do that?
Yes.
All right, so let's see if we can do that for me.
Just the lateral ones?
So let's find just the lateral.
Does that say 2.5?
Yes.
Sorry, I apparently don't have this packet.
Oh, see if I can.
I forgot to print it off the desk.
27.5?
2.5.
Is it? No, I'm saying would you multiply 8
Oh.
by, no. Would you multiply 11 by 2.5 and get 27.5? I didn't think you had to take your base.
Your base. So if we look at the two bases, this is a 2.5 by 8.
Okay.
So if I broke all these pieces apart, you could do it that way too, right? So if I had this skinny piece, that's the base.
Your screen's frozen.
Oh, damn it.
I was just letting you
Thank
know.
you. There we go. So if this skinny top piece is a base, and we have 2 of those, right? So this is a 2.5, and then this piece here would be 8, and that's 2.5 and 8. Now that's for my bases. For my lateral sides, I have these 2 vertically skinny pieces. So that's going to be 2.5, and that's going to be 11. 2.5 and 11, and then the big lateral pieces, those big rectangles, that's 11 and that's 8. 11 and 8.
That's what I did, is broke it down and then found like the area of each part and then added it together.
Right. So if I find this is, so this piece here is the laterals, right? So 11 times 2.5, 27.5, like Michaela said. And these are 88 each. So what do I do with those numbers, Lauren?
Add them together.
I add all these together. So the lateral surface area
Is 231 inches squared.
There we go. Right?
I agree.
So then the total would be what I got for my lateral surface plus what I would have for my bases. So 2.5 times 8 should be 20.
Yeah. And then, so 40.
So total surface area.
It's 271 inches squared.
Uh, 271 square inches. Does that make sense?
Yep.
Yep.
All right. Let's find the surface area of a cube. What's that going to be? I'll let y'all think about that.
Would it just be, so in this case, L times 6?
Why would you say 6?
Because it has 6 faces, right?
Uh-huh. So if I did each, so if I look at the net of this guy, this piece here is an L by L. So that's L squared. That's L squared. That's going to be L squared. That's going to be L squared. L squared. L squared. So I have 1, 2, 3, 4, 5, 6 L squares, just like Lauren said. All right, what about this pentagonal prism? So I have one of these. Hold on. Where did I put it? There you are. You're right next to me.
Oh.
So here's its base, its other base, and then each of its lateral faces. See, this would have been much cooler if we were in class, because then I could pass this around so y'all could actually see it. But now,
Hey, girl. Not much. I'm just in math.
and so here, if we look at it in its net form, we would have the right pentagon prism, and B stands for each of the area of the bases. And if we have these sides, we have these here. So consider this. So if B stands for that, show that the area of the surface area of the prism can be written as P times H plus 2 times B, where P is the perimeter of the base and H is the height. So what that's saying is that, so if this pentagon has sides S1, S2, S3, S4, S5, and the length of this is H, how can we come up with this formula for this prism? So if this was side 1, and
The
this
base is the top and bottom, right?
right, so this would have an area of B, and this has an area of B, right? That's what they just decided, that's what it is. Now, this one would be S1 times H would be the area of that rectangle, right? This would be S2 times that for that rectangle. S3 times that rectangle. S4 times H for that rectangle. And S5 times H for that last rectangle. So just like what we did in the other ones, we would add the area of the bases plus the area of the lateral faces. So surface area.
I have a question.
Yeah.
Why can't you just look at it as one big rectangle?
You could have done that too.
Okay.
So, and I'll show you that's what you would have gotten too. So if I did B plus B plus S1H plus S2H plus S3H plus S4H plus S5H. Now I can factor out the H, and I know B plus B is 2 of those B's. Well, just like Sophie said, the length of this rectangle here would be S1 plus S2 plus S3 plus S4 plus S5, which is what we have written here. So the area of that rectangle would be the length of that side times that side, which is what we have written here. But what do we notice what S1 plus S2 plus S3 plus S4 plus S5 would be? S1.
S10, isn't it?
No.
It'd
Wait.
be the length of it'd be the
S1.
length of one side of
So
the
S1 plus S2 plus S3 plus S4 plus S5 is
Oh,
the perimeter of that base.
yeah.
Right? So that's why they would write it as 2B plus PH. So that's where we get the formula for an area or a surface area of a prism. Does that make sense?
Okay.
So since we don't have table partners, so I guess with your window partners, y'all can discuss how we would do this. So I'm gonna pause my screen. And who's chatting at me? This keeps disappearing on me. Oh, that's cool. Y'all got really quiet. Oh, y'all are all muted. That's why. It's like it just got quiet.
So I'm kind of stuck, I guess. I broke it off, and then I have 2 sides. Oh wait, no, I have 3 sides. Never mind.
So
I figured
what
out.
we
I
have
figured out what I'm
here-
doing.
I have one of these too, don't I? I do. I do. It's a little one. So I have. So it's a triangular prism, right? So this is what I'm looking at. I have these 2 triangular bases. And then I have these 3 lateral sides. Oh, did y'all even see what I just shared to y'all? I just realized I was paused.
No.
Nope.
Oh, damn it. So I'm talking at you. So here's that shape that we're looking at, right? They have these 2 triangular bases, but then the sides are those lateral faces that are going to be rectangles, right? So we have a right triangular prism. So if I use that formula, surface area equals twice the base plus the perimeter of the base times the height. So what's the area of the base?
That's what I was confused on.
So the base is a triangle, right? So we got these triangles.
Oh, I got 132. Oh no, I got 120.
Oh, okay. So what'd you get for the area of the base?
Well, see, that's what I was going to ask you about. I broke it off into the 3 sides, so basically like 3 rectangles, and I got a different thing for
Okay,
each
so
side
these-
because I took.
Well, yeah, these are the lateral faces, though. I want to know.
Right,
what
but I didn't do the base.
Oh,
I
yeah.
didn't know.
We need the
Yeah.
base. We need the base
Oh, okay.
because we want the total surface area, right? We don't want the lateral surface area. We want the surface area.
So what do? You just take your centimeters and
So your base
Add
is
them
a
together?
triangle, right? And it's a right triangle, so you have a 3, a 4, and a 5.
And then you
So,
can make a rectangle.
so you have a 3, 4, 5 right triangle. Well, this could be my base, and that's my height, right? Because it forms a 90-degree angle, so I could reorient it to where it looks like this. So you have your base times your height, which is 12. divided by 2 is 6 centimeters squared.
And then you just have to multiply it by 2 all over again because there's 2 of them.
Right. Right?
Yes.
So I'm going to have a 12 centimeters squared for my 2B part. My perimeter of my base is 3 plus 4 plus 5. So if I said P is 3 plus 4 plus 5, that's 12. Let's make this where I can actually write this. So this is going to be 12 centimeters squared plus 12 centimeters times the height. So the length of that rectangle is 10 centimeters. So 12 centimeters squared plus 120 centimeters times centimeters is squared centimeters. And I heard somebody say this answer, 132 centimeters squared.
Yeah, that's what I got.
That's what I got. And that's what the people in the chat got too.
And do what?
The people in the chat said it too.
Oh, okay, I see it. So Ilsa and Katie. Okay. Awesome. Yeah. Sorry, Katie, I didn't see that until later. All right. What about this guy? So that's just a rectangular prism. Do I have one of you? Yes. So I have these two bases. And then those are my lateral bases. So if this guy is my base, what's the area of that base?
24.
24.
And then times 2 because there's 2.
So then 2B would be 48. So I'm getting my pieces for my formula, right? Because I want to find this, right? Now I need to find the perimeter of the base. What's the perimeter of this base?
200?
20.
No, 20, sorry. And then times 10.
Right, so the perimeter is 4 plus 6 plus 4 plus 6, which is 20 centimeters. The height is 10 centimeters. So if I put this together in that formula, the surface area equals 48 centimeters squared plus 20 centimeters times 10 centimeters, which is 48 centimeters squared plus 200 centimeters squared. And what did we get?
I got 248 centimeters squared.
Yes. Cool, right? So when I would be teaching these, I would have these 3D shapes. These sets are not terrible to buy. I think it's like $60 a set where you can build all of these things. They also have ones that are called a Sphera set where they're have curved edges where you can make cones and cylinders. And I think the Sphera ones are like $48 a set. So $100 for the 2 sets, and you can make a lot of these. So, but they're very hard to pull apart once you put them together. So I broke one. So studying
Uh-oh.
that. Okay, so surface area of a cylinder. So this is kind of using the same concept that we talked about when we were finding out the circumference formula for a circle. So if we have a cylinder and then we increase the number of edges, and then we increase the number of edges infinitely, it rounds it out to where we get this. And that's using calculus, but we don't do calculus. So, yeah. All right, so if we look at that, so if we want to find the surface area of this thing, we can technically slice off the top and the bottom and roll it out where it looks like this.
We pretty much already did these in a way.
Yeah. Yeah, because we talked about the nets when we were talking about 3D polygons or polyhedrons. And so here we're just now looking at how this relates to formulas of calculating areas. So if we have the same base, so if we look at the same idea here, that surface area is twice the area of the base plus the perimeter times the height, right? Well, in this case, we know the area of the base is 2 pi r, right? Oh no, that's the circumference. Come on, Joni. Area of the base is pi r squared. Here, I was like, we don't get a 4 in that formula. And then the perimeter, that's the circumference of the base. So that's going to be 2 pi r. So if I substitute these things in, I'll have the surface area for a cylinder. The cylinder or cylinder? Sure. So twice times the area of the base, which is pi r squared, plus the perimeter, which is the circumference, 2 pi r times the height, h. Does that make sense?
Yes.
Cool. Then we have surface area of a pyramid. So this one's a little different because we have to consider the faces, and when we find the height of those faces, because they're going to be triangles, we have to use this L, which is going to be called the slant height. And we have the base. So we have here is a square pyramid, and its net is below. So if I wanted to find its area, so if we take the number of sides, or sorry, the number of faces, and then of course, all of those are going to be triangles. So it'll be 1/2 times the base, the length of B here, times L, which is going to be the slant height. So in this case, for a square pyramid, we would take the number of faces, so that'll be lateral faces would be 1, 2, 3, 4 times 1/2 the length of the base times the slant height L plus the area of the base, which this would be little b squared. But as it turns out, they can simplify it. So if we take the number of faces, which is 4, times b, that would be the perimeter of the base. So you can simplify it, and this is how you'll see it written on formula sheets. 1/2 times the perimeter of the base times the slant height plus the area of the base.
That makes sense.
Yeah. A lot of students will get freaked out when they look at this because they forget what these letters mean. So I would really, really hone in, especially if you have students who are doing the standardized testing and they're given these formula sheets. Be sure they actually can identify what these variables mean. So see if we can figure out the area of this square pyramid. Let's see, do I have a square pyramid with me? I have a triangular prism. You don't have this square pyramid? I thought I had one. Fall on the floor. No, I just have a rectangular one. That's dumb. To visualize it, so this, you have these 4 lateral faces, and then there's your base. Granted, my base is a rectangle, so it's not a perfect square, but it will make it nice if it's square.
I got 96 centimeters squared.
I didn't get that, but I'll try it again.
96?
Yeah.
Okay.
I got 104.
I got 56.
We're getting things all over the map.
Six centimeters squared.
All right, so what is the perimeter of the base?
The perimeter of the base.
Oh, wait, hold on.
16 centimeters.
Whoops. Yeah, it is 56. Never mind. I accidentally did.
And then what's
We
the
were
slant
jumping
height?
on
5.
And the area of the base?
It's 16.
16,
Yeah, 16.
squared centimeters. So if
Yeah.
I plug
Okay.
these in, I get 1/2 times 16 centimeters times 5 centimeters plus 16 centimeters squared. So that's gonna be 40 centimeters squared.
56. Oh. I was just jumping ahead.
Okay. I was like, wait, what?
It's the 56 is the final answer.
That is the final answer.
Yeah, sorry. My bad.
So where did we figure out where we're getting these funky numbers from? Okay, cool. A word problem.
Wow.
So we have the Great Pyramid of Cheops is a right square pyramid with a height of 48 and a square base of perimeter 940. The altitude of each triangular face is 189 meters. The basic shape of the Transamerica building is a right square pyramid that has a height of 260 meters and a square base with a perimeter of 140. The altitude of each triangular face is 261. Due to the lateral surface areas of the two, how do they compare? So I have these two square pyramids.
Can you please pull it down a little bit? I didn't print off my packet. I can't read it.
Oh, sorry.
No, that's okay.
So there's one, and then we have this other one. I should do a different color, huh? So let's just say this is Cheops, and this is the Transamerican building. So for that guy, use a pencil. There's pencil. So if I wanted to figure out the right pyramid for Cheops, so if I look at the Cheops stats, it's a square pyramid, so that means its base is a square, and its perimeter is 940. So what is the length of this side?
It'd
How
be
would I figure that out?
235.
35.
It'll be 235, right?
Yeah.
So if I look at just one of those lateral faces, I know this is going to be 235. And they told me my altitude, did they give me that?
Yeah, 189.
189. All right. So that would mean, and I want to compare the lateral surface areas, right? So I don't care about the area of the base. So to find the lateral surface area, that's just going to be, so there's going to be 4 of those faces times the areas of each of these triangles. So that'll be 1/2 times 235 times 189, which comes out to be a big number, right? 88,830 meters squared.
Is it 235 times 189 or minus 189?
Times, make that look
Times.
like times. See if y'all can find the surface area. Knowing this now, if y'all can find the Trans-American building. So Lauren, you got 18,270.
That's what I got.
And that's what you got, Sophie. What about everybody else? Sarah, Cole. What about you, Emily?
We're still working on it.
Okay. That shouldn't be giving that.
I got 18,200, not 270.
Okay, so let's look at that then. So 140
I don't know why.
divided by 4 is 35. So that's going to be 4 times 1/2 times 35 times, and they gave me the altitude 261.
Yeah, Elsa, that's exactly what I did. My bad. I used
Got it?
261. I used the height, not the altitude.
Yeah, because you want the altitude of the
Yeah.
triangular face and not the height of the actual pyramid. And that'll give me 18,270. Yeah. All right. So how do these compare, Ilsa? Approximately, right? So how do we do that? So where did Elsa get this idea from? So what we could do is look at the ratio of Cheops area to the Trans-America Building area. So that's going to take 88830 divided by 18,270, which is approximately 4.9-ish or 5, depending on where you rounded to. So that would mean that the Cheops surface area is about 4.9 or 5 times bigger than that. Does that make sense?
Yes.
Cool. Now with a cone, we can do the same process like what we did with the cylinder. So if we just keep increasing the number of sides on our base infinitely many times, it will eventually round out to where we get this. And we end up getting that the surface area is the area of the base plus this lateral surface area is pi r L, where just r is the radius and L is the slant height of the cone. So we won't care about this piece here, this height here. We care about the slant height, so that's the one on the outside. Now, there are going to be problems where you are given the radius and the actual height of the cone, where you would have to use right triangles to figure out the slant height. So there's going to be problems like that in the homework and on quizzes. And then we have the area of a sphere. So what is the surface area of a sphere?
I have a question.
Yes.
Okay, so the cone, if you took off that top part, what shape would it look like?
You mean if you chopped it?
Yeah, like you do with the other one.
What do you mean?
You know what I'm saying? If you just took the lateral thing and you spread it out, what would it look like?
It looks like
Like the net.
Uh-huh. Yeah.
something like that.
Okay.
Because if like you sliced it down the side and cut out the bottom, it'll
Mhm.
round out like that. You never cut a snow cone funnel apart?
Okay, fair.
That's what it would be, right?
Or like a birthday hat.
Or a
Darn, I
birthday
have
hat.
to go because I have a
Oh
bio.
yeah, we're almost done.
Okay.
It's the last line,
Okay.
and I just want to tell you the area of a circle or surface area circle. It's going to be 4 pi r squared. And the great circle is the circle that has the largest surface area or largest area within that sphere, or the great sphere is the sphere circle on the sphere whose radius is equal to the radius of the actual sphere. Because technically you'll have all these smaller circles that you can draw inside there, but the great circle is the largest one. And that's pretty much it. And this actually leads into the idea of doing disk method when kids learn calculus. But we won't do that because we don't know integrals, but that's where that's going to end up going for them. And that's it. I will post.
Oh, okay.
I will
Sorry.
post-
Go ahead.
I will post a quiz for y'all, on Moodle for y'all, and turn it as a turn-in assignment, so that way y'all can have that as well, so we can keep practicing. And y'all have some homework problems here. So, and of course, definitely email me if y'all need anything. Okay?
Are you putting new course notes up?
And I will be doing that as well. I have to edit them a little bit.
Okay.
So
Cool.
yeah, 14.5 and chapter 9 will be coming up shortly.
Okay.
Cool.
Is there an answer key for quiz 8 up yet?
Not yet, but there will be.
Okay.
Will the quiz be up like right after this or later?
Give me a little in the afternoon here.
Okay.
When do you think you'll have our lesson plans graded by?
I'm working on that this weekend.
Okay.
So, on top of the 9 other things that are going on at the same time. So, I'm getting there. Slowly. Very slowly, but I'm getting there. So, yeah. But I want to make sure that you'll have at least 3 or 4 weeks to get those redos done. So, yeah. And plenty of time to maybe do a redo of the redo if y'all need it. So, since I know some of this is y'all's first lesson plan. So, yeah, I'm working on it. So be patient and I'll do my best. All right. Okay.
Thank you.
I'll see you guys. And again, of course, just let